Hello students, let's know about Fleming's left-hand rule. But before going through left-hand rule, I would like to tell you one thing, that magnetic field is a vector quantity. Yes, magnetic field is a vector quantity. Magnetic field represents magnitude as well as direction. I would like to repeat, magnetic field can be represented by two things, that is magnitude as well as direction. Magnitude represents value. Let us say if magnetic field's value is 30 and let us say it has direction in north, or let us say towards right or towards left, towards positive, towards negative, then this is represented by, let us say 30 is the magnitude and north is the direction. Students, Fleming's left hand rule is represented by your left hand's first finger. First finger is represented as magnetic field. That means this first finger is representing the magnetic field. Imagine this is my left hand and this finger is pointing in the direction of magnetic field. The second finger you have to open at the 90-degree angle with respect to the first finger. That means the second finger is representing the direction of electric current, and when you open the thumb, it is also at perpendicular to both the fingers. This thumb is representing the direction of force, or let us say motion. Let us watch one video to understand Fleming's left hand rule.
Fleming's left hand rule. In the earlier section, we studied about a motor. But how can we determine in which direction will this motor rotate if direction of magnetic field and current is given? We will discuss one rule, the Fleming's left-hand rule, on the basis of which we can find the direction of force, the rotating direction of armature coil, for the given direction of magnetic field and current. According to this rule, if you arrange your left hand in such a way that your thumb, first finger and second finger all point at right angles to one another, and if your first finger is pointing in the direction of the magnetic field, second finger is pointing towards the direction of current, then the thumb will give you the direction of the force. Let us check out the left-hand rule once more against the animation. Have you understood the rule? No? Okay. Now let's understand this by taking a simple circuit. Now arrange your left hand with thumb, first finger and second finger all pointing at right angles to one another. Now point your first finger in the direction of the magnetic field. Point your second finger in the direction of current. According to Fleming's left-hand rule, the thumb will give the direction of force. In this case, the conductor will experience a force in upward direction, or it will move up. Now, can you guess in which direction the conductor will experience a force if we reverse the direction of current?
Students, let us take one example to understand Fleming's left-hand rule. I would like to tell you that first finger is representing the direction of magnetic field. This is my left hand. And the second finger is representing the direction of current. As you can see here, the angle between when you open the first finger and after that when you are opening the second finger, there must be 90-degree angle between first and second finger. The first finger is representing or pointing the direction of magnetic field. The second finger is representing the direction of electric current, and when you open the thumb, this thumb is also perpendicular to both the values, and this is representing motion or force. So let us calculate one question, or let us understand one question. An electron enters a magnetic field at right angle to it. as shown in the figure, and the direction of force acting on the electron will be what? Whether it will be towards right or left or out of the page. For me, it is out of the board or it is inside the board. If you are writing in your notebook, then for you it will be out of the page or inside the page. Now my finger is pointing, I am using my left hand, my finger is pointing the direction of magnetic field. As magnetic field is a vector quantity. Second, I am going to open my second finger, but you are going to make a mistake if you are going to point the second finger in the direction of electrons, because as per the concept you know that electrons are the one who are going to form electric current. But as you don't know, the direction of electric current is always opposite to the direction of electrons moving. So my second finger is pointing in upward direction, which is actually the direction of electric current considered, and electrons are moving in downward direction. So when I open my thumb enters inside the board. As you can see, my thumb enters inside the board, and I can consider or select the option D, that is into the page. That means force is acting on electron into the page.